Checking, checking. Okay, morning. All right, so been wanting to work out this paper for a while. This is the June 2023 Pure Maths Unit 1, Paper 1. All right, time is running out. Exam is this week. And so I'm just kind of working this paper out. Shadi, this one is for you. This one is for you, Shadi. All right, hope you get cracking with your solutions. All right, so let's see if I can get this out the way quickly. I'm going to share it on YouTube for you and anybody else who wants to see it. All right, I think you're going to need a calculator, because remember this exam that you can use a calculator on. And there, see, here it is. And there actually are a number of questions on there that you can just solve with the calculator. To me, it's kind of ridiculous, but that's what it is. Fact of the matter, C6 students can use a calculator, but the allowing pure maths and advanced students use a calculator. But anyway, let's do this. Let me get the calculator. Let's just get the calculator up here. There it is. Make sure it is in radians. Yes, it is in, no, it's no in radians. All right. Let's do this as quickly as possible. First question. P, Q, and R are the propositions such that P is a statement that it is raining. Q is a statement that the sun is shining. R, there is a rainbow. It says the expression, it is raining, and that is your P. And that is your and. The sun is shining, that is your Q. But there is no rainbow. This but is another and. There is no rainbow means not R. Not R. So we're doing this and this. And then there's also no rainbow. So that is this one right here. So it is raining and the sun is shining. It is raining and the sun is shining. And there is no rainbow. That is it. Answer for the first one is B. This one says, if f of x is a modulus of x, which are the following diagrams is f of x plus 2. So what this means is that you have the f of x function, the modulus of x, which basically would be this. And that would be the modulus of x. But the plus 2 means that you have now moved it up 2 units. So let me draw this over. So I'm just going to do like a quick sketch of what happened. Right? So it is like you have, if I were to draw it on this diagram, let me draw it by itself. So it's like you have y-axis, x-axis, and you have, let's use colors. So I'm going to put purple for the modulus of x, which is this one, modulus of x. And then this plus 2 means that you slide it up 2 units. And so they move it up here 2 units. Up to 2. That is the modulus of x plus 2. And so this is the graph that you're looking for. And it is the very first one, as you can see. This one is the answer right here. All right. What would this one be? Let's try what this one would be. This one would be, because we're on 2 units to the left, this one would actually be the modulus of x plus 2. That's what that one would be. Because if you notice, when x equals minus 2, you're getting 0. all right? And when the x equals 0, right here, you get in 2. That's what that would be. Because it's like you have the modulus of x this way, and when the plus 2, you move it 2 units to the left. All right, so that is that graph. That's what this one would be. This one would be the modulus of x minus 2. The slided modulus of x graph 2 units down. And this one would be the modulus of x minus 2. Modulus of x minus 2. Because you take the modulus of x graph and slide it 2 places to the right. You can check this one. Because when x equals 2 here, you get in 0. All right, and that is it. And up here, when x equals 0, you get the modulus of negative 2, which becomes a 2. All right, so that would be that one. All right, so that is that. So, all right, so in other words, this one would be f of x minus 2. This one would be f of x plus 2, if they were to ask it. And this one would be f of x minus 2. All right, I'm just putting on those in case I change the question. All right, let's go. Number 3. So this one, basically, you're rationalizing the denominator because they give you this and you want to rationalize the denominator. So all these answers are rational denominators. So once you rationalize the denominator of this, you multiply numerator and denominator by the conjugate. So it becomes root x minus root y over root x plus root y. You're going to multiply numerator and denominator by the conjugate of the denominator. So I multiply the denominator by root x minus root y. Multiply numerator by the same thing, root x minus root y. So you see that the denominator is the difference of 2 squares. It becomes root x squared minus root y squared. And the numerator becomes a perfect square of root x minus y, root y, all squared. All right, so maybe I'm showing too much work. But then this expands out into, the numerator expands out into square this, you're gonna get x. Then twice the product of the 2, you're gonna get minus 2 root x root y. And then the second term square this plus x. Oh, plus y, sorry, plus y. When you square this, you're gonna get a y. And dividing that by this square minus that square becomes x minus y. So this answer is actually the last one right here. The x plus y is this x plus y. And you minus twice this. This product that we are seeing here is the same as this. And divided by x minus y. So the answer is really the last one here. All right, you already did too much work there. This question. I'm gonna put this modulus of x thing somewhere. Let me shift this away a little bit. Let's shift this away. Put it maybe here. Yeah. All right. So we're doing this one now. This one once gives us these two functions in the form of tables with the values, and they want g to minus 1 of f of x, of f of 3. So we're gonna do the f of 3 first. So what is f of 3? F of 3 means you're mapping this 3 onto this 2. All right, f of 3 is 2. All right, so that becomes a 2. So now this becomes g to the minus 1 of 2. So you want to reverse 2 on the g function. That's what this is. So like you're taking this 2 on the g function and you're reversing the mapping to 5. So therefore g to the minus 1 of 2 is going to be 5. But the inverse function must give you back an x value now. So the function is a y value. That's why this is a y value. which is this 2. And then the inverse here is giving a back an x part is mapping the 2 back to 5. A range value of 2 back to a domain value of 5. So the answer here is 5. Nice and easy. Next one. The contrapositive of this statement, if JOMA is a minor, all right, then, all right, so looking at if P then Q. So this is your P, and this is your Q. All right, and if a statement, if a conditional statement, if a conditional statement, conditional, so I thought the conditional, I was trying to make some space. All right, let's put it up here. All right, so the conditional statement, conditional is P implies Q. If P then Q, then the contrapositive, you flip this around and negate them, so it becomes not Q implies not P. That's what it is. So you're basically trying to write this statement for the contrapositive. All right. So you want to not this implies not that. All right, let's look for that now. So you want JOMO, if JOMO is not rich, if JOMO is not rich, that is a not Q, then E is not a minor. That is it. So this would be your, this is the implies, right? E implies Q. That's what we have. So this would be now your JOMO is not rich. This would be your not Q. This is your imply. Then E is not a minor, meaning you're not P. All right, because P is E is a minor, so not P E is not a minor. JOMO, last one. JOMO is not a minor. Right, so the answer is this one. This is it. It's a different color. So we have said the contrapositive. Right? Because the P is JOMO is a minor. So JOMO is not a minor here. E is not a minor. And this is called the antecedent and the consequent. So you switch them around, right? So you do the negation of the consequent, which is JOMO is not rich. You do the negation of the antecedent. E is not a minor. That is it. Enough time on that. Next question. So give us this equation, well, this polynomial, and it says P of A is 0. Meaning we'll substitute A or alpha for the X, you're getting 0. All right. Well, the first thing I look at this, I see that this can be factorized. All right, and then we can put it equals 0 on the alpha. All right, let's factorize it first. So factorize this first. It would be x. It's going to be 12 each and 4 and 3 each. No, 4 each and 3 each. 4 each and 3 each. And then the middle term is a minus. So you're going to put the minus here and plus here. Right, that's what factorizes into. And then now you want to put it equals 0 on the alpha. So on the alpha, you're going to put it equals 0. So when x equals alpha, we're going to get alpha minus 4h into alpha plus 3h equals 0. So it's either this equals 0 or this equals 0. But I want the h to be a subject. So like I put in this equal to 0, you know, we're making H a subject. And I put in this equal to 0, making H a subject. All right, so let's write out the two of them. Alpha minus 4H equals 0 would imply that the H equal alpha over 4 and the alpha plus 3H equals 0 would imply that the H equal minus alpha over 3. So those are the two values, alpha over 4 minus alpha over 3. Looks like A is the answer. That's it. Let's try this a little bit better right here. So this will be minus alpha over 3. I'll put these two arrows in red. All right, so this is that is this. It's either this or that equals 0. All right, and I'm going to put the alpha equals 0 here. Now we could say P of alpha equals 0. P of alpha equals 0 gives us this. All right, next question. I'm doing all this writing because eventually I'm going to just share this document with the solutions on it, right? So that's why I'm trying to put some work on it rather than just get the answers. This one here now. Maybe I can just use the full screen until I'm ready for the calculator. So this one gives us this function. It's a quadratic and it wants us to the range of positive values of x such f of x is 1 to 1. All right. So what happens is that that's a small shape quadratic function. For it to be 1 to 1, you have to use either half of it over here or half of it over there. All right, you have to take out the term. So these are all greater than 0. So basically, you want to find where the turning point is. So you can complete the square and write f of x as f of x, complete the square, factorize the 3 first. I could say the turning point is at x equal minus b over 2a, you know. That's where the x value is at the turning point, you know, minus b over 2a. But if you complete the square, you're gonna find it still into x squared minus this is gonna become 2x plus 1. So if you complete the square inside here, you're gonna get 3 into x minus 1 squared, and you're subtracting by the square of this, which is 1, and then you're adding back 1 out here. The important thing though is that the turning point is where x equals 0. X where this equals 0. So that's where the turning point is. So the minimum point where it turns is where x equals 1 inside here. All right, and you want to go to the right of that. You want to go to the right of this because you only want half of the graph that starts at this point where x equals 1. You don't want this half of the graph. All right, you don't want the right half of the graph for it to be 1 to 1. Because remember, if you have the whole graph, then it will fail the horizontal line test. So that's why you only want this half of the graph. And so you want it is 1 to 1 when x is greater than 1. All right, but I found the turning point x value by doing minus b, which would be minus a negative 6, minus negative 6 over 2 times the 3, which will become 6 over 6, which is 1 in way, right? To be the x value turning point. I've been known that way as well. But anyway, that is that. That is it. Next part says, given that x is less than y, x and y are real numbers, which are the following expression is true. And I look at it and know that this is the answer. You know? Why? Because the modulus of an expression is always positive. So this has to be true regardless of the values of x and y. So this is the answer. You know? Because modulus will always be greater than 0. So because they're not the same, then the difference will never be 0. That's why it will always be greater than 0. I'll put another way. If you have this expression which is x less than y. So we can transpose the y. And then this then tells us that the x minus y is less than 0, meaning it's a negative. Right? It's a value. There's a value on it. But if you take the modulus, it's automatically going to become greater than 0. Whether this is it's actually negative, right? But for example, if this works out to -2, this side, I take the modulus of it, then it's going to become 2, which is greater than 0. All right. So this is the answer. This one is not true because modulus can be negative, so this one is not true. So we can X out the ones that are not true. This is not true. Over here, it's not true that if you take the modulus of both sides, you're gonna get like this. It's not true that if you take modulus of both sides, because if you have, if for example you have, if for example the x is say -2, for example, if you have -2, it is less than 0, right? If I'm putting this as my x, if I'm putting this as my x less than y, I'm making my y be 0. When I take the modulus of this side, I'm getting 2. Modulus of -2 is not less than the modulus of 0, because this actually becomes 2. And 2 is greater than 0. So that's why this one would not be true. So this one is not true. And then again, there's a similar thing with this one. This one, right? Because if I can use values, it's positive values now for this one, right? So for this one, I can use that x is less than y. I'm going to put 2 is less than 3. And then if I negate this side, I'm going to get -2. And then if I take the modulus of this side, it is still 3. That's it. The sign is still less than. So therefore, this one is not true because they have a greater than. Right? So this is not true as well. In any case, the last one is the answer, right? Because this is true. Regardless of the value of x and y, the modulus is always greater than 0. So that's why that one is true. Let's continue. Let me put a little example here. So, example is for the document. Example, -2 is less than 0, but the modulus of -2 is greater than 0. Because the modulus of -2 is 2. It's greater than 0. That's why this is the answer, using that as an example. All right, because the x minus y, because the x is less than y, then x minus y is less than 0. So it could be a value like -2. All right, let's continue. This one gives us this expression, and they say it is divided by this. So if you divide by this, if you divide by this, then I am finding, if I divide by this, if I call this f of t or f of x, this is f of x, and I'm finding f of t. All right. When I divide it by this, the remainder is f of t. So putting t everywhere in this. So it's going to become, this is going to become t to the 4th power. It's going to be t to the 4th power as well. T to the 4th power as well. And this is already t to the 4th power. So it becomes 4 times t to the 4th power. So the answer is this one. All right, that is that. Next question. Here's a question that can be used. You can use a calculator to do it. You can just type this in the calculator and get the answer. Right? But then you can use the laws of log to do it, right? But this can be done with a calculator. All right, so bringing everything to base 8 first. So I'm going to take this 3 and put it up here. take this 2 and put it up here as well, right? So I'm gonna get log to base 8 of 18 plus log to base 8 of this 2 cube becomes 8 minus log to base 8. I'm gonna put this 2 up here. I get 3 squared is 9. All right, this is actually 1 enough, but I'm going to use the laws of logs, right? So here I'm going to multiply these. It becomes a log to base 8. Multiply these, I get 18 times this 8. Divided by this 9. So it becomes, this cancels into that 2 times. So it becomes log to base 8 of 2 times 8. I think I'm doing too much work, you know. When I can do, could I just use my calculator? All right, 2 times 8. 2 times 8 is correct, yes, because 9 into this goes 2 times. All right, so then it becomes log to base 8 of 2. It's too much work, this, you know. Log to base 8 of 2 times log to base 8 of 8. That's what this product becomes. No, not times, plus. Oh, wow, plus. And then, too much work, too much work. This is 1. And this one is, this one log to base 8 of 2. Too much work, too much work, too much work on this, too much work. All right, I want this to become an 8. So I raise it to a power 3 and then take back a third. Raise it to a power 3 to make it become an 8. I want it to become an 8. So I raise it to power 3. And then it's like I want to cancel that 3. So I'll put a third over here. All right, so too much work, Mr. Shaw. This becomes now 1 because this is an 8. This becomes 1 plus a third. So I get a third plus, and this is 1. So I get 1 and a third, which is 4 over 3. Too much work, this, you know. I could just use a calculator. Too much work. If you have to do it over. It's too much work, too much work. Too much work, Mr. Shaw. Too much work, too much work. Too much work. Let me see. It's too much work. Too much work. All right, leave it. It's too much work, but it's all right. This one. All right, so for this one, I'm gonna change the base of this. And I'm trying to get log to base 2. So I'm gonna write this as this. I'm gonna change the base. I'm write it as log to base 2 of 16 over log to base 2 of A, which is what I want, equals 5. I'm trying to make this a subject. But log to base 2 of 8 of that 16 can be written as, right, this as 2 to the 4th power. So it becomes log to base 2 of 2 to the 4th power. I'm going to cross multiply with this and this, right? I'm going to put this over 5 and put the log to base 2 of 8 over on this side of A. Log to base 2 of A. And this expression becomes a 4. All right, so this becomes a 4. This 4 comes to the front. This 4 comes to the front, and this becomes a 1. So it becomes 4 over 5. So the answer is this one, 4 over 5. All right, so the log to base 2 of A becomes 4 over 5. All right, leaving that 4 comes to the front. So it comes 4 or 5. I'm going to make this smaller. Let me see it look on the page. Yeah, you can make this smaller. Let's make this smaller and write another line. And so I'm going to end up getting 4 log to base 2 of 2 over 5 equals log to base 2 of 8. And I can tell you there are multiple ways to do this, but that's the nature of logs. This expression is equal to 1. Right? This is equal to 1. So that's what answers 4 or 5. Multiple ways to do this thing. Multiple ways to do this. I'm thinking that I could have put this as a reciprocal and write it instead as, let's do it here, as another way. But I written this side as log as 1 over log to base 16 of 8 equals 5. No, that doesn't make too much work. Yeah, doesn't make too much work. I think bringing it to base 2 is the best way. All right, let's continue. Number 12. This one says, which are the following? Which are the following intervals are in this domain? In this domain, all right, in the domain of this function, all right. So you're basically looking for what values you cannot take. All right, so first, let's look at it. First thing is that the x under here can be negative because you're doing the square root. All right, so that expression for the square root of x part, your x has to be greater than or equal to 0. Can't find greater than a negative number. And then for this denominator, can't be 0. Can't divide by 0. So your x squared minus 9 cannot be 0. So the x cannot be plus or minus 3. All right. So what are the answers here? We're trying to make this valid on. So first thing, you have to be greater than 0. That's what this is saying. That's this part. And then the x can be 3. X can be 3. So that's why you have, well, it has to be greater. This is true, but first you have to be greater than equal to 0. That is true. You can't accept this because this would include a value like -2. So you cannot accept this one. You cannot accept 1. Right? You cannot accept this either because this will also include maybe a value like -1. If you say x is greater than -2, they include a value like -1. Right? So you can't accept this either. So this is the only value you can accept. This one is true. You have to be less than 3, and you can't equal 3. No, so notice we can't equal 3. So you can be less than 3, but you also can be greater than 0. Which are the following is in the domain? Yes, in the domain. It's not saying it's a full domain, but it's in the domain. So this is in the domain. 2 only is in the domain. So basically the answer is this one. All right, that is it. This one is out because it would include a value like -2. And you can't put -2 in there. You can't find a square root of -2. You also, this also can't put 3. If you put 3 here, you're getting 0. You can't divide by 0. And this one would include a value like -1, for example. You can't put -1 in there. You can't find a square root of -1. That's why the first and the third one out of it. Only two we can accept. Only 2. All right, so that is that. Next question. The modulus of 3 over x So it's a modulus function, all part of it above the x-axis, right? So this one out of it, this one look like actually 3 over x. It's like 3 over x straight. This one is 3 over x. This one is actually 3 over x without the modulus. So this is not the answer I want. All right. This one looks like x squared. That's not what you want. And this one looks like y equals x. All right. This is the answer. Modulus, every part of it is above the x-axis. So straightforward. That's straightforward question. All right. You cannot accept this because you can't use any part that is below the x-axis. Similarly, you can't use this any part of it that is below the x-axis. That is it. All right. Next question right here. It says, given that f of x is equal to this, if k is greater than x is greater than k, and real, they want f to the minus 1. They want the inverse of this function. We're going to use x and y. So like this is y equal this thing, right? Y equals e to the 2x plus k. And forming the inverse. So the inverse, we're not just interchange the x and the y. The inverse would be that x is equal to e to the 2y plus k. When we find this y, we have found our inverse. So basically trying to make this a subject. Transpose the k first. You're going to get x minus k equals e to the 2y. Let's spread it out because I want to take ln of both sides now, right? Let's spread it out. You're going to get e to the 2y. You're going to take the ln of both sides. So you're going to ln this side and ln this side. And then after ln that side, this 2y comes to the front. And you end up getting ln x minus k equals 2y. The 2y comes to the front. Around that. This 2y comes to the front here. And then the ln e is 1. Let me write it in the bracket. ln e is 1. ln e equals 1. I'm putting all this work on the paper because, as I said, I'm going to share the document, right? And I want to get y, I just need to divide by this 2. Right? Divide by the 2. And so we end up getting y equals half of ln x minus k. And this half can actually come up here now. But they haven't done it. This is it right here. All right, so this is the inverse right here. All right, half ln x minus k. Next one, sum of the squares. Sum of the squares of this equation. The sum of the squares of this equation. Of the roots, some of the squares of the roots. All right, so they're basically talking about some of the squares. Alpha squared plus beta squared plus lambda squared. What is that equal to? That is equal to alpha plus beta plus lambda all squared minus 2 times the pairwise products. Product of roots pairwise, twice the product, which is alpha beta plus alpha lambda plus beta lambda. Right? That's what that's equal to. So the question is, what is alpha plus beta plus lambda? It is minus b over a squared minus 2 times. What is the pairwise product? It is c over a. That's what we're working out. The a and the b and the c are the coefficients up here. So the a is this 4. The b is this positive 3. The c is this negative 2. There's no need for the d. But if you wanted it, the D is this 1. But the D is not going to be used here. So then we're really working out down here now. Minus B, which is minus 3, minus this 3 over the A, which is 4. Now you're squaring that. Minus 2 times the C. The C is negative 2. Negative 2 over the A again, which is 4. That's what they're working out. All right. Again, I cannot drop that in the calculator, but still, this becomes 9 over 16. This becomes plus. This actually becomes 1, right? This is actually 1 plus 1. But 1 is the same as 16 over 16. So it becomes 25 over 16, which is this last answer down here. This is the same as 1 plus 1, 16 over 16. All right, 25 over 16. Next one says the equation of a circle. This going to the normal. All right, going to the normal. Going to the normal to the circle at the point 0, 0. So that is the origin, right? So the question is, where is the center of the circle? The center of the circle is going to be minus 2, 0. Minus 2 because of this, 0 because this is same as 1 minus 0 squared. You have to understand this, right? That's the center. And this point is on the x-axis. And then you want the normal. The normal pass through both points. And so normal is actually x-axis, y equals 0. You see the gradient is a horizontal line. So the gradient is 0. So it's like you have the circle. And the circle is like this. And this is the x-axis. And you want the 0.00, put them in red. 0, 0. And you have this point, negative 2, 0 is the center right here. Negative 2, 0. And so the normal becomes the x-axis. This becomes the normal, which is the x-axis. The normal is the x-axis. Normal. The normal is the x-axis. And the gradient is 0. The gradient equals 0. Right? So this is the answer right here. Funny plus that. Horizontal line gradient. Sometimes these simple questions give problems, you know. Simple question like this give problems. Because the gradient is just that horizontal line passing through the center, which is negative 2, 0, which is on the x-axis, and I want it the normal at the point 0, 0. Right? Which is a point on the circle. That is it. All right. Yes, that is correct. It is correct. Angle between these two vectors. There's a pi by 2 here. I can maybe calculate the scalar product. I mean, to get the angle, we're going to calculate the scalar product anyways. But let's see what the scalar product is. And if the scalar product is 0, then the angle between them is this pi by 2, 90 degrees. Let's see. Scalar product A dot B. Work it out in blooms to show. A dot B. Scalar product. It becomes this times this, which is 2. And then this times this, which is minus 4. And then this times this, which is 2. And that is equal to 0. So the scalar product is 0. Angle is 90 degrees. 90 degrees, which is pi by 2 radians. So the answer is this one. Easy question. The scalar product is 0. Angle equals 90 degrees. Angle angle is. Let's write it out. Angle is 90 degrees. Angle is 90 degrees. When the scalar approaches 0, the angle between them is 90 degrees. All right, next one. What's the minimum value of this? All right, so basically it's your R. So you have this expression, can be written in the form R sine theta minus alpha. This can be written in this form. All right. But the minimum value is minus R. The minimum is minus R. Right? Because this part of it cannot be between 1 and -1, this part of it. So the minimum is minus R when this is -1. So the minimum overall is minus R when this is -1. What is the R? The R is the square root. So it becomes minus. Let's write it, the minus, put back the minus on it. It becomes minus. And the R is the square root of A squared plus B squared. That's 8 squared plus 5 squared. That's what it becomes. All right, so it's minus square root. That's going to be 89, because it's 64 plus 25, 89. The square root of 89. Answer is this one. All right, this one says y squared is this, xy is 6. It says the intersect at 3 points. It says the y coordinates of these 3 points. All right. So basically, then we want to eliminate the x. We want to find the y values. We want to eliminate the x from these two equations. What I'm going to do to eliminate this x, since I have xy here, I want to take this equation and I'm going to multiply it with y. And this will become an xy, same as that. So when I do that, I'm going to get y cubed equals xy plus 7y. So this is 6, remember? This is equal to 6. This is equal to 6 from here. So the equation becomes y cubed equals 6 plus 7y. And I have this now. I'm going to use trial and error. I'm not going to work out everything. I'm not going to solve this. I'm going to use trial and error as a process of elimination to get my answer. All right. So I can use a value like, try a value like 1 first. Because if I get 1, if 1 don't work, then it will eliminate these 2. So let's try 1 first. Trial and error. I will have space to do the work. So I'm going to use trial and error in red. So try y equals 1. So I'm going to have 1 cubed. That 1 don't work. 1 don't work. 1 cube is 1. All right? 1 cube equals 6 plus 7 times 1, which is 4, right? So 1 doesn't work. So this is eliminated. And this is eliminated, right? These two, because the 1 doesn't work. Eliminate that and eliminate that. So it's either these values no. No, sorry. These values no. So it don't make no sense to try -1, because -1 is in both of them. So I can maybe try the 3. Because if 3 doesn't work, then this is the answer. If the 3 works, then this is the answer. So I'm going to try 3. So try y equals 3. Trial and error. So if I try y equals 3, I'm going to get 3 cubed equals 6 plus 7 times 3. Is this true? This is 27, and this is 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. Is this true? This is 27, and this is 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27. So yes. So this one doesn't work. I can put an X on this, but this one does work. 6 plus 7 times 3. 27 All right? So you know the answer is the first one because 3 worked. So this one out of it as well. Because 3 work and there's no 3 in this one, right? So the answer is here. Am I correct? 1 didn't work. -1 work? Yes, -1 would work. All right, so if you don't know, you can just try the other values, like -2. That would be -8 equals 6 plus 7 times -2. But the -2 cubed is -8. And yes, this will be -8. That's -14 plus 6. And the -1 would work because you would get -1 cubed equals 6 and 7 times -1. 7 times -1. That will give you -1 equals -1. So, right, answer is A. So this question, not solving it, I use a process of elimination. I get the answer quickly. Just these 2 calculations, I get the answer. Right? So eliminate the 1 first. You eliminate these 2. Eliminate this one because the 1 doesn't work. I eliminate that one. So either this or this will be the answer. And then no, it don't make no sense to try the 1 because the -1, but -1 is on both of them. So that they're gonna try the -2 or they're gonna try the 3. All right, so that's how you'd approach this question. Let's use elimination to get it. All right, let's go. Number 20. Number 20. Almost halfway. There's only 45%. This one says the curve whose Cartesian equation is that may be expressed in parametric equations. All right, so this is basically using up sin squared plus cos squared equals 1. So based on these, the one with the sign is the first one. So basically then is like, this is your sine squared. Sine squared t is equal to this, plus this is the cos squared. Cos squared t is equal to 1. All right? So if that is the case, then if you take the square off of these, you can clearly see, let's put it in blue, you can clearly see that the sine of t will be equal to just x minus 3 over 4. So you have a square root this 16 and I get 4. And if that is the case, what will be the x? Making x a subject. So the x would be 4 sine t plus 3. That will be the x, right? Multiply out the 4 and then add this 3. All right, so 4 sine t plus 3. There's just one answer alone with that. This is one answer with that, you know. So this is the answer down here. This is the only answer with 3 plus 4 sine t for x. This one. This is not it. This has a minus in it. This is a minus in it. This is a minus in it. So the answer is this one down here. I don't have to work out the y. But if you want to work out the y, you could go ahead and say the cos of t based on this would be y plus 4 over 3. Because you have to square with this. Now you have to write that as 3 squared at 9. They make y the subject now. You're going to get the y equals, multiply the 3 and then subtract the 4. So it will be 3 cos of t, 3 cos of t, 3 cos of t minus 4. There, 3 cos t minus 4. Good. So the answer is that last one. Nice and easy. We could have gotten it just after you got the x one, right? All right, next one says the gradient of a straight line perpendicular to this. The gradient, so you want the negative reciprocal gradient. Then you get gradient of this one. So you put in the form y equals mx plus c. This is like an advanced question, you know. Like y the subject. The y would be minus 3 over 2x minus 2. Good? If I make y the subject. So like I care over the 3x first and make it negative, and then I divide by this 2. Like I care of this 4 become negative 4, and then I divide by this 2 become negative 2. So we're going to have this line. We're going to have this line 1 is minus 3 over 2. So we're going to have the second line is minus 1 over the going to have this first line, which means I flip this and change the sign, you get 2/3. It's an odd math question. You know, C6 should be able to do this. All right, that is it. Minus 3 over 2 flips to 2/3. And you change this and then change the sign. All right. This one gives us this expression, and it's basically writing this in the R cos formula, right? So R cos. So this is going to be written in the form of R cos of theta. Since this is a plus, you need a minus here, alpha. Minus alpha. All right. Now, if you notice, you have root 10 for everything, so you have to worry about that. Because why is that? Because the R is the square root of a squared plus b squared. R is the square root of 1 squared plus 3 squared. That's why the R is equal to root 10. Because up here, the A is going to be 1 and the B is going to be 3. A is the coefficient of this cos and the B is coefficient of that sine, 3. Then now the alpha. Alpha is tan to the minus 1 of B over A. The alpha is tan to the minus 1 of always the B over the A. So it's tan to the minus 1 of 3 over 1. That is the alpha. So let's go now. Tan to the minus 1 means arctan. So it's arctan of 3. So alpha becomes arctan of 3. So the root 10 is God given. And you're looking for the minus alpha, which is minus arctan of 3. So inside this first one here. And says B. All right, tan to the minus 1 of B over A, guys. Remember, it's B over A. Tan to the minus 1 of B over A. Let me write stuff here. Alpha is tan to the minus 1 of B over A. A sets up the right tree. B over A, not A over B. B over A. Since it is R cos. Write it over. Tan to the minus 1 of B over A. The B is 3. All right, let's continue down here. This one now, just this to see which one of these it is. All right, so first thing I notice is that this 1 plus cos is gone. So it means that the numerator must have 1 plus cos in it somewhere to be cancelled out to get rid of that. All right, that's what I'm noticing. So I'm going to introduce a cos on here. So to introduce a cos, I'm going to write this sign as tan times cos. Because remember, I put it up here. If tan theta is sine theta over cos theta, then I can multiply the cos here and write that sine theta is tan theta times cos theta. That's why I'm going to introduce my cos. By replacing this sine theta here with this. All right, I'm going to shift this over someone here. All right, so this expression is going to become, tan theta cos theta plus tan theta all over 1 plus cos theta. 1 plus cos theta. Why did I get that? Because I replaced this with that. Underline for those who get the document, or those who get the document. going to factorize the tan out of these two terms. So I'm going to get tan theta into, from this I'm going to get 1, from this I'm going to get cos theta plus cos theta. I did it that way because that's what I have on the denominator here, over 1 plus cos theta. And then they cancel. 1 plus cos theta cancels with 1 plus cos theta. All right, I don't have to mark up the paper, but that is it. So the result then is tan theta. So this is the answer right here. Nice and easy. Tan theta. Those cancel. These two bracketed terms cancel each other. All right, down here. This one said the path of one object is given parametrically as those. What is the slope at? It is the slope of a tangent at t equals pi by 4. So basically, I need a gradient, right? The slope is dy by dx. So we need to calculate dy by dx. So we're calculating dy by dx, which is then equal to, you differentiate the y, differentiate that one. We differentiate cos, you get minus sign. So I'm going to put minus sine of t over. We differentiate sine, you get cos times dx. You have to differentiate this x1. This I'm going to get cos t, cos of t. Now sine over cos is tan, so this is really minus tan of t. But the t is pi by 4, so it's minus the tan of pi by 4. The tan of pi by 4 is 1. It becomes negative 1. So the answer is right here. Negative 1. This could have been an advanced paper as well. No, lie. It's parametric equation. Don't put it on advanced paper. All right, next one. This one says express as a product of two trigs. What is this? That's the, what we call a factor formula. That's the sum of two sines. Sum of two sines is sine cos. Twice the sine of half the sum times the cos of half the difference. Sum of two sines is this. Twice this becomes twice the sine of half the sum, I mean theta plus 3 theta over 2 times the cos of half the difference and the cos. I'll put that a little bit lower because this number 29 in the way. Let's put this lower. Times the cos of half the difference, which is theta minus 3 theta over 2. So it becomes 2 times the sine, but this now becomes 4 theta over 2, which becomes 2 theta. And it's become the cos of minus theta, right? Because that's minus 2 theta over 2 minus theta. But the cos of minus theta is the same as the cos of theta. That's what you have to know. So it's the same as 2 sine of 2 theta cos of theta. Let's put a note here. That note. The cos of an angle, cos of minus an angle, I should say. Cos of minus theta is equal to the cos of theta. That's what you have to know, guys. So then say the first one, A, right here. That's why this becomes this. That is it. That is it. Next one. Says the circle with equations that and that, these two circles. The circle this cuts this circle in two distinct places. The equation of the common chord. You basically solving these two equations simultaneously. To get the common chord, you have to subtract them. To eliminate the square terms, you subtract them. So call this equation 1, for example. Call this equation 1. Call this equation 2. I'm going to subtract them. to get the final result. Let's do it down here. So I want to do equation 1 minus equation 2. All right. All right, let's do equation 1 minus equation 2. It doesn't really matter. 1 minus 2. So first thing, the x squared will eliminate the x squared. And the y squared will eliminate the y squared. Then we're doing minus 2x minus a negative 8x. That becomes minus 2x plus 8x. So that's 6x. I'm getting 6x. Then I'm getting minus 6y minus a negative 8y. That's minus 6y plus 8y. That's plus 2y. Then I'm getting 1 minus 30. That's negative 30. 1 minus 31 is negative 30. And then 0 minus 0 is just 0. And you divide this through by 2. You divide through by 2, you're going to get 3x plus y minus 15 equals 0. 3x plus y minus 15. See it here? This one. That's your common cause. Remember, when you're solving two equations of circles simultaneously, the first you do expand them out in the general form. That's called the general form. And then you subtract them to get this line. And if you want to find the points now, you just solve simultaneously the line and one of the equations. Either that one, or you solve simultaneously the line on the first equation. Solve them the line, the intersecting line, or that common chord line simultaneously with one of the circles. That's how you get the points. But this question only wanted that common chord. All right, so that is that. Then this one says the vector u has this magnitude and is parallel to this vector v. It says a unit vector parallel to u. Now, once it is parallel vectors have the same unit vector. So you can basically say that the unit vector of u in the direction of u is the same as the unit vector of v, because the parallel vectors have the same unit vector. Look at it that way. And the unit vector is the same for parallel vectors. And all vectors in the same direction have the same unit vector. Every direction has a unit vector. Anyway you want to look at it. So we're calculating the unit vector of this to get the answer, which is 1 over the modulus of the vector times the vector itself. What is the modulus? 1 over the square root of 1 squared plus 2 squared times the vector, which is I plus 2j. And this analysis becomes a 5. So it's 1 over the square root of 5 times I plus 2j. And that is it. 1 over root 5. I, in that plus one is minus 2j. Let's change these to minus. It's minus. All right, 1 over root 5. I minus 2j. So this is it. Easy. This one says curve C has parametric equations, this and this. Cartesian equation. This is almost like a repeat, because you're just going to use sine squared plus cos squared equals 1, right? Sine squared theta, we'll have the x1 first, right? Sine squared theta plus cos squared theta is equal to 1. So from this, the sine theta is x over 4. So this becomes x over 4 squared plus, and the cos theta is y over 3. It becomes y over 3 squared equals 1. This is x squared over 16 plus y squared over 9 equals 1. So to get rid of these denominators, because I don't want any fraction, I'm going to multiply it through by the product of 16 and 9. All right. Multiply through by 16 times 9. Now the 16 times 9, that's 144. Yes, it is 144. Because 16 times 9 is the same as 4 times 4 times 3 times 3, which is 12 times 12, right? So it's 144. Good. So I'm going to multiply 2 by the 144 now. Times, let's write 16 times 9. All right. Multiply 2 by 16 times 9, which is 144. When I do that, this becomes 9x squared, because the 16 cancels, so I get 9x squared. This becomes 16y squared because the 9 cancels, so I get plus 16y squared. And this becomes a 144. That's what you're looking for. 9y squared, 16y squared, 144. That is it. All right. That is that. Next one. So the vector equation of this line, of a line to these points, is what? So remember, it is a plus lambda times lambda t, lambda times b, where a is a point, and one of the points, this one or this one, looks like they're using this one, right? Here and here and here. So you know that is one of those three answer. But then the b is the direction. What's the direction? The direction is the AB vector. So the b is the vector AB, which is OB minus OA. All right. So basically doing this point minus this point. Okay, this is the answer in the last one. Because 1 minus 3 is negative 2. Negative 2 is right as a column vector. And then minus 1 minus 4 is negative 5. And then 6 minus a negative 7 becomes 6 plus 7 is 13. That is a B. And the A is just this vector. All right, so I have the A right here. That answer the last one. See there? Minus 2 minus 5, 13. So the answer is this one. This becomes a A, and this is a B. All right, so that's the last one right here. Okay. And A is just this point up here. Portion vector of this point. This is A in this expression. Portion vector of that. Those coordinates gives you A. All right, that's that. Number 30. Winding down. These are the portion vector of these. That's P and that's Q. Once it's telling the length of PQ. So I'm going to find PQ first. So first, the PQ is OQ minus OP. As a column vector, that's this minus that, which is negative 3. This minus that, 4 minus a negative 1 is 5. 4 minus 8 is negative 4. Then the modulus of PQ, the length is the modulus, right? It becomes the square root of 3 squared, 5 squared, 4 squared. That's these values. All right, and that's the working out. 3 squared, 4 squared, 5 squared, 3 squared, 5 squared, and 4 squared. If you have to, just use a calculator. Get this one. I feel like using the calculator for this one. So the square root of 3 squared plus 5 squared, which is 25, plus 4 squared. And let's see what that is in thirds form. 5 root 2, which is this answer right here. All right, can use the calculator, use it. All right, differentiation now. So this one is to differentiate that. That's a product rule we're going to be using, right? So what we're going to do, let's write it up here. Keep the first and differentiate the second. So I'm going to get x cubed, differentiate the sin x to get cos x, plus keep the second, which is the sin x, and differentiate the first. We differentiate this, you're going to get 3x squared. And you keep in the second, which is the sin x. That's what we're looking for. Which answers that. But then I factorize x squared out of it, right? All right, so if I factorize x squared out of it, I'm going to get x squared into x cos x plus 3 sin x. That's what I'm looking for now. X cos x. All right, this is another. That's just cos x. X cos x plus 3 sin x. So then set this one. And this is factorized to that. All right, that is it. Next one. But I really make the paper tight. This one says a curve is defined by that equation, given that x increases at a rate at 1 unit per second. So this x increase at a rate of 1 unit per second. That means dx by dt is equal to 1, you know. All right. When x equals 1, what is the corresponding rate of increase of y? They're asking for dy by dt. So dy by dt is the product of 2 rates of change. Dy goes on top this one. Dt goes on the bottom of the second one. It's a chain rule. So dx goes here and there. So dx goes here and dx goes there. And so we need to calculate dy by dx from this. And then substitute the 1. So we're at a space. So we put some of this information over here. Put this information over here. Put x equals 1 over here. And then shift this up. Let's zoom in and write smaller. Let this out smaller there. All right, so we need to differentiate this now, because this is 1, you know. Right? This is just 1. So that won't change anything. So the answer basically is to differentiate this, differentiate that expression, and then substitute x equals 1 in it, because this is 1. So this becomes equal to, differentiating this now, you're gonna get minus 10 into 1 minus 2x, reduce this power by 1 to 1, and then multiply by the differential of what's inside, which is a negative 2. And then multiplying that by this 1, the one that this is 1. That's what this is. This is this 1 over there. All right. And you're plugging in this x equals 1 now in everything. So it's going to become, this is negative 10. You plug 1 inside here, you're going to get negative 1, because this x is 1, times a negative 2, times this 1. That one becomes immaterial. So you're gonna get a negative answer, negative answer, negative 20. Because these two negatives cancel and make it positive. So negative 10 times 2 is negative 20 right here. So that says negative 20. All right. Remember what we did, we put x equals 1 in this, right? X equals 1. That's what we have. That's how we get this here. Because x is equal to 1 here inside this. All right. Let's do a thing for the purpose of the document. So this expression becomes this. Because we did x equals 1 to get that. All right. So we get 1 minus 2, which is negative 1. Put by this times 1 out here. Times 1. So that's a negative 20 in the end. Okay, let's underline these as well. This is this. It's a different color. This is rose blue. This is that. All right, that's for the document. Then we have this expression. I want to differentiate it twice. This differentiate it twice. I must space. We have some space somewhere here. Differentiate the first time. We're gonna get dy by dx equals differentiating this. To differentiate this first, we're gonna get 3 is 9 x squared. Yeah, differentiate cos, you're gonna get minus sign. So first, this minus is gonna become a plus. Continue to a plus from now. We also have to differentiate this 5x and get 5, and then 5 times 4 is 20. I remember it's gonna become sine of 5x. Sine of 5x. We're gonna differentiate this again. So we differentiate this one, we're gonna get 18x. We differentiate sine this time, we're gonna get cos, same positive cos. We differentiate the 5x first, we're gonna get 5. 5 times 20 is 100. I differentiate the sine 5x, we get cos 5x. And that's the answer right there. Answer the last one. Down here. No, if we differentiate it again. Oh yeah, we did. So let me put this as my second derivative. Put this as my second derivative. So d2y by dx squared. When I differentiate this again, I get that. That is it. Okay. Next part up here. Once us to differentiate, this is a quotient, right? Differentiate that quotient rule. So dy by dx becomes, start with the bottom and end with the bottom. So you say right at the bottom first, which is 2x plus 1. Then differentiate the top. Differentiate the top, we get 3. They subtract the top, which is the 3x plus 1. They differentiate the bottom. We differentiate the 2x plus 1. You're going to get 2. They put everything over the bottom squared. 2x plus 1 squared. And then simplify, right? All right. So I'm going to expand out the top first. Can work it out now. We can say, in terms of the x, we're going to get 2x times 3, that's 6x. And then minus 6x. So the 6x gone, x gone up of the numerator, right? In terms of the numbers now, you're gonna get 3 times 1 is 3 minus 2 times 1 is 2. So getting 3 minus 2 on the numerator, which is 1 over the bottom squared, which is 2x plus 1 all squared. So the answer is this guy right here. That's the answer. Quotient rule down here. The limit as x tends to 3 of this, and factorize the numerator, and it becomes a limit as x tends to 3 of x minus 3 times x plus 3 over x minus 3. And then these cancel each other. That and that cancel each other. And so we're really doing the limit as x tends to 3 of x plus 3 now. And so it becomes equal to 3 plus 3 when you apply the limit, which is this 6 right here. All right, next one. Which of the following functions is discontinuous? All right, so the function that is discontinuous is 1, where the denominator can be 0. So this one is continuous, you know, when x equals -1. If x equals -1, we get a -1 over 0, which is undefined. So this one is continuous, you know. But this question weird. This denominator can be negative, can be 0, because you're squaring this. This also can ever be negative. So under here will always be greater than 0. So this one okay. This one is not discontinuous. This one is discontinuous. But this one discontinuous too, you know. Because I can't find the square root of a negative number. So I don't understand why they put this one there. I cannot find the square root of a negative number. And this can be negative. Because for example, if the x equals 4, then you'll be doing the square root of 9 minus 16. Which you can't find out. This is not real. So this one's supposed to be discontinuous too, you know. So this question is kind of really funny, you get me? This question is fun. So I'm gonna put any answer, and it's supposed to be the two of them. This one I would say is discontinuous. And this one is also discontinuous because there's a value that you can't find. You can't find square root of negative. You do have in the value, for example, x equals 4. And this one definitely discontinuous at x equals -1. And maybe this is the answer that they want to know. But then I also discontinuous as well. Because once you can't get real values, the function becomes discontinuous. Because you can't work out any real value for this. Right? Or maybe this one okay, you know, because you're not putting in any value. You see, the problem is because they don't specify in the domain, right? All right, let's put it this way. Or we know up here, the x can be -1. Right? X cannot be -1 down here for that one. But for this one, I'm just trying to see if possibly this is the answer. This one is acceptable. Which doesn't make sense to me, but you're basically saying that the 9 minus x squared has to be greater than or equal to 0, you know. Has to be. Which means that x squared minus 9 has to be less than or equal to 0. Which means that the x has to be between 3 and -3 for the function to be continuous. Right? That's what's happening in this one. Right? The x has to be less than or equal to 3 and greater than or equal to -3. Can't be outside of that for this one. So this continuous in this range, you know. And this one continuous everywhere. The question is, which of the following real function is discontinuous? This function only okay. I guess maybe it's this one, you know, because it's continuous in that range and it don't exist outside of that. So let's see if he has the answer, yeah, man. Because what happens is that like you're going along and then only when you get to x equals -1, you can't get a value. So the x cannot be -1. That's what we're basically saying for this one. But this one now, it is continuous within the range. It is continuous where the x values are valid. So I guess maybe the answer is A. Because for values less than -1 or greater than -1, the function is continuous, and then it just breaks at x equals -1. Where this one is continuous for the whole range from -3 to 3. All right, so I guess that's it. That's what I would say. I'll leave one as the answer. But I don't like that question though. Don't like it. Don't like it. All right. F prime is equal to that. F double prime is 6x, right? F prime of 0 is 0. C is a constant. Oh, so what I want us to do is find f of x. So I have to integrate this 2 times. All right. So firstly, f prime, integrate this 1 time. F prime of x is going to be the integral of 6x dx, which becomes add 1 to the power and divide by the new power. You're going to get 3x squared. 3x squared plus some constant, the first constant. But I tell you here to get a constant, f of 0 is 0. So f of 0 is 0. So the c equals 0. Right? Let me shift this over. So from here, f of 0, f prime of 0, sorry, is 0. So mean that when I put 0 in here, 0 in here, everything this side becomes 0. This is 0. So the c is 0. All right, so f prime, so c is 0. Therefore, c1 is 0. And you want f of x now. So f of x then becomes the integral of 3x squared dx. Because this is 0, so that's gone. So you're integrating this now to get f prime. So you're going to get x cubed. Okay, add 1 to the power, you're going to get x cubed over 3. 3 cancels, so that's going to get x cubed plus c. So f of x is x cubed plus c. Last one. That is it. You can differentiate the back to get that. So differentiate it first, you're going to get 3x squared. And then differentiate it again, you're going to get 6x. So that's it. So the 6x is the answer that you have is good. All right, 38. Give us this to differentiate twice. So remember now that this is the same as y equals 2x plus 1 to the power half. So you can see the power you're working with instead of the square root. So firstly, dy by dx first up equals differentiating this. So you're going to get a half bracket 2x plus 1 to the minus half. You multiply by differentials inside here. So you times that by 2. So initially you're getting 2x plus 1 to the minus half. Because this 2 cancels a half out there. Then that's dy by dx right now. Then to get the second derivative, d2y by dx squared, you have to differentiate this again. So you're going to get minus half into 2x plus 1. Subtract this 1 from this again, you're going to get minus 3 over 2, because minus half minus 1 is minus 3 over 2 times the differential of what's inside there again, which is another 2. So what do we get? This 2 cancels this 2 with a minus 1 here. This negative 4 means reciprocal. I'm going to put it now as 1 over. This 2 means square root of this expression cubed, which is 2x plus 1 cubed. Answer this one, you know. This one is the answer. This one is the answer. Why is that one the answer, Mr. Shaw? Tell them why this one is the answer. Oh, it's a minus. Again, I did have a minus. So this one is the answer. Start a minus. It's supposed to be a minus. Don't give it away. -1. All right. Now, this cube thing, it has a square in it. And the square in that will give me this whole, well, actually this one. And then the other one of this root, give me that one. So basically, maybe what I need to do is write this instead as this square root of 2x plus 1 all cubed. Yeah, because this can be like this. So the minus is why I brought the expression beneath there because of the minus. The 2 and the diameter of that power is the root. And this 3 is the power that I raised the root to. Now this cube means that it can be broken out into the same expression squared times back the same thing. And then the squared part is just this. And then the root. So the last one is the answer. So here. Same as that. Next question. I'll go 6 questions left. It says the gradient of the normal to this curve at x equals 1. So first we're going to get dy by dx, which is a tangent. You get the gradient of a tangent first. It's 6x minus 2. Differentiate this, we get 6x. Differentiate this, we get 2. At x equals 1, we're going to get the gradient of a tangent. So the gradient of a tangent becomes 6 times 2 minus 2. That's 12. That's 10, right? No. 6 or 1 is 1. X equals 1. Why am I putting 2? 6 times 1 minus 2. That's 4. So the gradient of the normal is -1 over the gradient of a tangent, which is -1 over 4. This one. Add my students could do this one as well. So the gradient of the normal. That's it. That's the gradient of a tangent. Divided by dx of x equals 1. Number 40 gives us this curve. So the total area A and B is given as, so on the area from 0 to 4, then because this is on the below the axis, this B below the axis, we're going to take the modulus of the area between 4 and 5. All right, so which one is it? 0 to 4 first. See it here, 0 to 4. And you have to add the modulus from 4 to 5. So then says this one. That's it. 0 to 4 gives you above the axis, that gives you E. And you take the modulus of the B part and add it. So for this one, they didn't put the modulus on here now. The minus area of this could have worked because the minus will give you a plus. But usually they work with the modulus. All right, let's finish up 4 questions there. 41. It says the displacement S of a marble moving along a board at time t minutes is given as that. Find the value of t. Find the value of, or what value of t is the displacement of the marble increasing. It's increasing when the gradient is positive. So when ds by dt, rate of change of displacement is greater than 0. That's what they're trying to find. So differentiating this and putting it greater than 0. Simple as that. Differentiate this, you're going to get 12t squared. Differentiate this, I'm going to get minus 60t. Differentiate this, I'm going to get plus 72 greater than 0. Gradient is increasing. This can be divided through by what? 12. That's 12. All right, let's continue. Divide through by 12. Divide this by 12. We're going to get t squared. Divide this by 12. We're going to get 5t. Divide this by 12. We're going to get 6 greater than 0. So it's like a normal quadratic with a small shape. Let's solve it. And let's factorize it first. So we can see what is happening. So we're going to factorize it first. Greater than 0. So we get t. Signs are the same, they are both negative. So it's 2 and 3 now, not 6 and 1, 2 and 3. So it's 2 and 3. Both signs negative, minus, minus. So between 2 and 3, now you're outside of 2 and 3, outside of 2 and 3, because greater than 0. So if you sketch it, it will be a smile shaped t function, 2 and 3, and you want above the axis, say coming out here, but you want up here now, greater than 0. So coming to the left of this 2 and to the right of that 3. So the t will be less than 2 over here. The t will be greater than 3. That's what you want, less than 2, greater than 3. But then the t can be 0, right? So this is it, you know. Less than 2, greater than 3. But they say greater than or equal to 0 because they start at 0. That's why I have this part here. All right, but this is the answer right here. Less than 2. But greater or equal to 0 for time can negative. And greater than 3. That's it. For 2. So finish now. This one says it's an advanced question as well. It's an advanced paper. Integral from 2. They tell us that this is 12. And they want us to work this out, right? Okay. All right, so I want to break this up. So this is going to become the integral from 2 to 3 of f of x. I'm going to leave out the dx for now, right? And let's put it. I'll split this up. I'm going to get plus the integral from 3 to 4 of f of x dx. And then minus this, minus the integral of 1 dx from 3 to 4. So them two parts, yes or no? This and this. Them equal the integral from 2 to 4. If I do the integral from 2 to 3, then add in 3 to 4 of the same function. So it becomes the integral from 2 to 4. So that becomes the integral of f of x from 2 to 4 dx. And you're going to subtract the part in blue. But this can be worked out now. This is just a sum from 3 to thing, you know. Because it becomes x between 4 and 3. That is just 1. So this then becomes 12. That's what it is, minus 1. So it's 12 minus 1, which is this 11 right here. But this part is 12 minus 1. That's it. Part 3. Portion of a curve y equals 2x between x equals a and b rotated 360 degrees about the x-axis. The volume V of a solid generated is best represented by, and remember, volume is pi, don't forget the pi, times the integral of y squared dx. So you have to square this, and you're going between a and b. So the volume becomes pi times the integral from a to b, or the y squared is squaring that. You're going to get 4x squared dx. That's what we're looking for. So it looks like this. See, look at this. This is dy now. It's dx you want. Be careful. This is the answer. It looks so alike. All right. So the 4 pi here, 4 pi, 4 pi. So I put the 4 outside and the pi inside. Same difference. X squared dx. All right. That's it. 15a and b. Number 43. 2 to go. So radius of a circle is increasing at a rate of 0.1. That's dr by dt is 0.1. They just gave us. It's at the instant when r equals 3, the rate of increase of the area. They're asking us for dA by dt. Connect the rate of change again. It's become the product of 2 rates of change. dA goes on top of the first one here. dt goes on the denominator of the second one. The third variable is r. dr goes here, dr goes there. We need to find dA by dr. We're going to get that from the formula for area of a circle. Area of a circle is just pi r squared. So it means then that dA by dr is 2 pi r. Let me differentiate this. So I'm going to take the 2 pi r and bring it right here. And then the 0.1 is coming there. All right, so this then becomes 2 pi r times 0.1. Because when r equals 3, so then it becomes 2 pi times 3 times 0.1. That becomes 0.6. 0.6 pi. 0.6 is same as 3 over 5. It's same as 6 over 10. So it's 3 over 5. This is 3 over 5 pi. So inside this 3 over 5 pi. Why did you put it as a fraction? No problem. That is it. Next one, last question. To integrate this between 0 and pi by 2. All right, so firstly, I'm going to write it, the 2 outside here. So it becomes 2 into, integrate cost, you're going to get sine, because you differentiate sine, you get cost, but then you have to divide by the differential of this 5x. So I'm going to put a 5 out here. And put a 5 out here. Take out the 2. Take this 5 and divide it out here. And then inside here, I'm getting the cos of the sine. So the sine of 5x between pi by 2 and 0. That's what I'm working out. If you differentiate this again, you're going to get back that. You want to try it. If you differentiate the 5x, you're going to get cancel the 5. And then the 2 is there, and it becomes cos x. All right, so it becomes 2/5 into sine of 5 pi by 2 minus the sine of 5 times 0. 5 times 0 is 0. And that's what we're working on. Just need to know the sine of 5 pi by 2 now. Calculator. And that looks like 1 in a. 2/5 is the answer. Let's see. That's 5 pi by 2 is 2.5. All right, so let's work this out now. Let's put everything in the calculator. 2/5 bracket sine of 5 pi over 2. See, we're getting 2/5 as the answer. 0.4 is 2/5. The answer is just 2/5. So this answer is 2 over 5. The answer is right here. And that is it. That is that. So I'm going to end it now. 2 over 5. Okay, Miss Shadi. That is it. Bye. See you later.